Good morning, class. Let's start the day with a quick check. I'd like for you to pause the video and do these three problems. Include these in your notes. Pause now. For this first problem, I'd like to use the method we call looking inside, and I need to kind of be able to tell what this expression has to equal. To do that, I'm going to need to isolate the square root portion of this equation first. So I'm going to begin by adding 20 to each side, so this becomes 5 times the square root of 5x minus 10 is equal to 5 plus 20 is 25. And then if I divide both sides by 5, we get the 5 times 5x minus 10, the square root of that would equal 5. Now, the only way that this entire thing can equal 5 is if the thing inside is 25. And if you're not real comfortable with your roots, like finding square roots, one thing you can do is you can just square this 5. When you do that, you can see that becomes 25. So the thing inside must be 25. So this, right, 5x minus 10 must be 25. Therefore, 5x must be equal to 35. And therefore, x must equal the number 7. And again, if I plug that back into here, 5 times 7 is 35. 35 minus 10 is 25. Square root of 25 is 5. 5 times this 5 is 25, and 25 minus 20 is indeed 5. So that checks. Our technique for solving the exponential equations, equations that have variables that live in the exponents, this year anyways, is to rewrite the bases. And the two bases that I see here is I have a base of 2 and I have a base of 1/2. So I'm going to migrate these bases to 2. I know 2 to the 0 power is the number 1. 2 to the first is 2. I'm not going to change that. Going the opposite direction, 2 to the negative first power is exactly 1/2. So that's what I'm going to use to replace 1/2. I'm going to rewrite it as 2 to the negative first. On the left hand side, I just have 2 to the 2x minus 1 power. On the right hand side, it's going to be 2 to the negative 1 power. Right? This is exactly equal to 1/2. So I just rewrote that. They're the same. And then I'm going to raise that to the x minus 4 power. On the right hand side now I'm going to use the power to a power rule. So I've got the power of negative 1 rather, and I'm raising that to the x minus 4 power. When I raise that power to the new power, it's going to become 2 to the negative x plus 4. Very important that we see that, right? The negative 1 is multiplying this entire exponent. And then over on the other side, we've got 2 to the 2x minus 1 power. Now that my bases are exactly the same, I can set my exponents equal to each other. When I set the exponents equal to each other, I get that 2x minus 1 is the same as the opposite of x plus 4. Adding an x to each side, and then adding a 1 to both sides. And then finally, when I divide both sides by 3, I get that x is 5/3. Very nice to take an answer like this and plug it in the original expression and make sure that this does indeed make both sides the same. So this final problem, I'm going to use fraction busters, and when I look across the fractions in the three terms I have, there's 2 terms on the left hand side and 1 term on the right hand side, I can see that I'm going to need a factor of 2, a factor of 3, and a factor of x to completely eliminate these fractions. So that I could just write it as 6 times x, but leaving it this way helps kind of reveal the giant ones that I'm going to be eliminating. So you can see I've made room in each one of my numerators, and what I'm going to do is just bring in these factors of 2, 3x to each one. So I've got a 3 times a 2 times a 3 times an x, 4 times a 2 times a 3 times an x, 10 times a 2 times a 3 times an x. And doing that kind of makes it very clear exactly what can be eliminated. So here we've got this 2 over 2 is the one that's gone. Over here we've got the 3 over 3 which is the one that's eliminated. And finally, way over here, we have x over x that's eliminated. So this equation becomes, the first term is going to become just, oh, there's another giant one I can eliminate. Also over here, there's an x over x, it should be gone as well. So that first term is going to just become the number 6, plus the next term is going to become 4 times 2 times x, so 8x. And on the other side, this is going to equal 6 times 10, which is 60. If I take away 6 from each side, I get that 8x is 54. Yeah. Oh, I'm glad that didn't take me too long. I would have gotten a wrong answer and would have had to check it and spent a lot of time trying to figure it out. But I can see my error right here. These are factors, and thank you. I can hear some of you shouting at me. I appreciate that. When I multiply 3 times 3, I get the number 9. So this is not 6. 3 times 3 is the number 9. That's what I should take away from both sides. And when I do that, I get the number 51. So my answer, x, is 51/8. And I believe 51 might be prime. No, actually, you can divide that by I think 3 and 17. I just think it's relatively prime to 8. So there's no common factors there. So that's the answer that I would use to check. And based on my snafu, I'm going to check that off screen. And I encourage you to do so as well. All right, so let's move on to today's topic. So the title for 423 is Why Can't Studies Determine Cause and Effect? And this is a cautionary tale. Basically, the bottom line is association is not causation. So we've been looking at variables that are associated with each other, and typically we can see the associations, and I'm very careful to use that word almost exclusively, that when x increases, we'll see y increase or y decrease, and we'll come up with a linear model that describes that association. But we're always very careful to not say that the variable x is causing y to move up or down. We're just saying the two variables are associated with each other. Let's just kind of read the intro here. It says, a study found that the more hours students spend on activities outside of school, the higher their grades tend to be. Does that mean if you sign up for more activities, your grades will go up? Another study found a link between how often you brush your teeth and the reduction in heart disease. Does that mean if you brush your teeth twice a day, your heart will be healthier? As a consumer of statistical information, you need to be aware of the difference between association and causation. Today's investigations will explore the difference between the two. Fire hose and different diameter. Oh, fire hoses come in different diameters. How far the hose can throw water depends on the diameter of the hose. The Smallville Fire Department collected data about their fire hoses. The residual plot for their data is shown at right. So the first thing I want to just say here is when we look at this residual plot, right? The residual plot indicates something about the nature of this relationship. And I'm going to leave you to tell me exactly what this residual plot indicates about the nature of that relationship. And if you want, I recommend if you could use a doc with this, and you could invite some members of your group to join in and share in answering these questions, and you can discuss them. But part A say, what does the residual plot tell you about the least square regression line model the fire department used? What does this residual plot tell you about it? Next it says, determine the worst prediction made with the least square regression line. How different was the worst prediction from what was actually observed? Explain what this means in context. So one of those is the worst prediction, and what does that mean in terms of the remember the residuals here are feet that the hose was able to throw the water, and then the x values are hose diameter. And then finally, make a conjecture about what the original scatter plot might have looked like and sketch it. Label both axes. So you're not going to have exactly what this original scatter plot looks like, but if you look at the residual plot, you can come up with a pretty good guess as to what it might have looked like. And again, when we talk about the least square regression line, we're saying that they were using a linear model for these. So So think the original one was linear. And if I'm going too fast through these, remember you can always open up the ebook. This is question number 80. Question 81. The mayor of Smallville finds the following graph in the town's annual financial report. Describe the association, if any, in the scatter plot. So let me just open up the graph so we can see just it. This is the graph. And we can see that I think that looks like there's a linear association between two variables. And I'm just going to leave it for you to tell me what that association is in this context. And when I say in context, I'm always talking about what's the x-axis, what's the y-axis, what does slope mean in this context, what does a y-intercept mean. The mayor immediately ordered the fire department to send fewer firefighters to each fire so that there is less damage. Why do you think the mayor said this? Do you agree with the mayor's decision? Explain why or why not. So we've got question 80 and 81 you are answering. Question 82. A dietitian studying the benefit of eating spinach surveyed a large sample of individuals. She recorded the amount of spinach they ate and their physical strength. The dietitian found the spinach eaters tended to be much stronger than the non-spinach eaters. The next day, the newspaper headline was, "Popeye was right, eating spinach makes you stronger." Do you agree with the newspaper? Do you agree that if you eat more spinach, you will grow stronger muscles and increase your strength? The dietitian correctly found an association. What could explain the association other than spinach makes you stronger? What could explain could explain this association other than it's the spinach that's making you stronger? Nice. So that is question 82. So I'm looking for responses for A and B. Okay, so 83 we're not responding to, but this is important because of the vocabulary here. So a lurking variable is a hidden variable that was not part of the study. The size of the fire in problem 81 and the amount people work out in problem 84 are probably both lurking variables, right? So if you think about it, the larger the fire, the more fire trucks you're going to send. It's not that the firefighters get there and cause the fire to be larger. We sent more fires because it was a larger fire to start with, and it's not the spinach that's making the people stronger. It's perhaps the case that people that eat more spinach just tend to work out more. Or working out is something that's sitting behind those two. A medical study found a strong link between the number of hours high school students wear a helmet and the number of concussions, head injuries. Huh. Interesting. A medical study found a strong link between the number of hours high school students wear a helmet and the number of concussions, head injuries. However, it's unlikely that wearing helmets cause head injuries. Can you think of a lurking variable that might explain this association? So again, I'm not looking for a response for 83. I'm just kind of thinking out loud, but I know that I see people that riding their bikes a lot wear the helmets. People on scooters wear their helmets. People with the skateboards or the roller skates wear the helmets. So it just could be that the people that are wearing helmets more, rock climbers, are engaging in activities where, or football players, they're engaging activities where they're likely to have a head injury. It's not that the helmet's causing it, it's just the activity that's behind that. Question 84. A web of associated variables, like the ones shown below, can get complex and difficult to unravel. Consider a medical study focused on hearing loss. It may associate variables like eating prunes to hearing loss as strongly as it associates an actual cause like long-term noise exposure to hearing loss. Okay, that's fun. Let me look at this. So if we look at it, there's a lot of associations here that are not causal, clearly not causal. So if you are a senior citizen, you're more likely to have false teeth just because you've been around longer and your teeth have probably suffered more damage. Same thing with long-term noise exposure. The older you are, the more likely you've been exposed to long-term noise, loud noises. But be careful with your headphones because that can happen younger in life, earlier in life too. But you're looking at this and you can say senior citizens tend to have more false teeth, right? And false teeth is associated with hearing loss. So the more false teeth you have, the likelier you're to have worse hearing. Clearly, the false teeth or eating prunes are not causing the hearing loss, right? It's just the fact that you're a senior citizen. Senior citizens are more likely to have gray hair. That does not cause hearing loss. That's just an association. So this is just a few variables, but you can imagine people that are looking at studies, and there's a lot of things that go into what are potential lurking variables, what's the big picture that's sitting behind everything. So it's definitely an important thing to be aware of. Let's finish with one last problem. By the way, I don't want you to write any response to this question at all. I just want to make sure that you have seen this diagram and you understand the idea of lurking variables and these things, these web of associated variables. The last question that I want you to respond to today, however, is question 85. And it says, come up with your own original news headline. And I've seen some recent ones that might be inspirations for you, but I'd like it to be something that maybe I haven't seen. You don't know what I've seen. The first sentence should contain a reasonable link between two variables. The second statement should be a clear misrepresentation of the link. Two examples are given below, and you may not use either one of these. The first one is facial tissue linked to cold and flu. So that's the statement, facial tissue linked to cold and flu. Statement 2, Surgeon General calls for a shift to paper towels. Okay. The other example is statement 1, bathing suits tied to sunburns. Okay. Uh, Doctors recommend swim naked. So please come up with an original statement. Two statements just like this. Again, the first one is a reasonable link, and then the second one is a misrepresentation of the first. So today in your notes, I'm looking for not actually a lot of notes, just the three problems that we did at the beginning, and then a response to question 80, a response to question 81, A and B, a response to question 82, so 80, 81, 82, no 83, no 84, but also a response to 85. All right, this is Mr. Roberts, and I will talk to you soon.